Let's now continue our discussion in study guide for module number 4 under the topic Geometric Design for Highways and Railways. Now before we proceed to our discussion, let's go first to the highway alignment in 3 dimensions. Now looking at this figure, this is what a driver will see as he drives a highway. So in this highway alignment in 3 dimension, we are able to see here this width and elevation of the highway, the curves here. Now let's divide that into 2. The first one is the plan view. This is how the highway looks like when you look at the top, and this is the plan view or the horizontal alignment of the highway. Now how about if we look at it on the side? We are looking at the profile view or the vertical alignment of the highway. Now so far, under the plan view or the horizontal alignment of the highway, we were able to discuss that topic, passing sight distance, wherein you can see here the highway in the top view. Whereas the profile view, we were able to discuss that in stopping sight distance, but here the highway is level, or the level of the highway is horizontal, but we're looking at it in the side of the profile view. Now this time we will go to the 2 profile views. We have the crest vertical curves and the sag vertical curves. Under the crest vertical curves, or also known as the summit curves, here the grade goes upward, or this positive, then later on goes downward or negative. Whereas under the sag vertical curves, we have the grade going downward or negative grade, then goes upward or positive grade. Now today, we will be discussing the sight distance for vertical curves, but the first one here is the crest or the summit vertical curves. Now, when the sight distance S is lesser than the length of the curve L, then we will be using this formula, where A is the difference in grade, wherein G1 is the first grade, and then G2, then they're both in percent. Now, when the sight distance is greater than the length of the curve, then we will be using this formula. So we will have the sample problems, then let's apply the formulas given there. The first one, example number 1, is a 5% grade intersects a negative 3.4% grade at station 1 plus 990 of elevation 42.30 meters. Design a vertical summit parabolic curve connecting the 2 tangent grades to conform with the following safe stopping sight distance specifications. Number 1, we have the design velocity equal to 60 kilometers per hour. The height of driver's eye from the road pavement is 1.37 meters. So here, the H1 was given as the height of the driver's eye towards the road pavement. So here we go, that is our H1. Then, height of an object over the pavement ahead is 100 mm. Now, for the height of the object here, that will be H2. Perception reaction time is equal to 3/4 of a second. Whereas coefficient of friction between the road pavement and the tires is 0.15. The first one is determine the stopping sight distance. Now let's use this figure for the problem. So H1 is what? 0.37 meters, whereas H2 is 0.10 meter. Now we are here to compute for the S, or the stopping site distance, but with the grade. The grade is 5%, then later on it becomes 3.4 or negative 3.4%. Now from the previous video, we have discussed the how we solve for the stopping site distance. Now for the stopping site distance, we have there S equals VT plus V squared all over 2G multiplied by F plus G. Okay, that is from our previous video. Now the V here should be converted into meter per second. Given our velocity, our design velocity is 60 kilometers per hour. We will be multiplying it with 3,600 seconds. Then we have the 1 hour, and then we have 1,000 meters in 1 kilometer, and that is equal to 16.67 meters per second. Now substituting to the formula, we have there 16.67. Perception reaction time was given as 3/4 of a second, plus velocity 16.67, that is squared twice of gravity. Then we have the grade, the friction of 0.15, 4.15. Then we will be using the first grade that it encounters, which is the 5%. So 5%, 0.05. Then that is equal to, using our calculator, the value will become, so that is 83.32 meters. So that is for the stopping side distance. Now next we will be solving for the length of the curve. So for the length of the curve, so we will choose either this one or that one. So let's make some assumptions. For example, maybe the assumption here is that S, or the stopping site distance, is greater than L. Well, anyway, there's nothing wrong with making some assumptions, because if the final answer, or if it does not satisfy the assumption, then the assumption is wrong. Then we will proceed to use the other formula. So again, we assume that S is greater than L. So these are the conditions for that assumption. Okay. So we already have here S. So we have the value of S for 83.32 already. We have the value for H1 and H2. The H1 and H2 is given here, 1.37 and 0.10. Okay. Now, what's missing is the value of A, or the difference in grade. Now for A is equal to G1 minus G2 in percent. It says there it is in percent. So this is 5 minus negative 3.4%. So A now is equal to 8.4%. Next, using the formula, we have there L is equal to 2S minus 200 times the square root of H1 plus the square root of H2 squared over A. Let's use that. So 2 times the S is 83.32 minus 200 square root of the H1 1.37 plus the square root of H2 of 0.10 10 squared all over the A of 8.4. So our answer here is 114.03 meters. Now, is our assumption correct? Remember that we assume that S is greater than L. So here in our solution, it seems like 114.03 is greater than S, which is equal to 83.32. So here, what does it mean? We have wrong assumption. Therefore, we will use S is less than L. If we will be using S is less than L, so we go to letter A. Now, using this formula for this assumption, then let's try to solve for the L. So we have there L is equal to the A of 8.4%. Are we correct? Is it 8.4? Yeah. 8.4% times the S of 80. That is 83.32 squared all over 100 times square root of 2 times 1.37 plus square root of 2 times 0.10 squared. Using our calculator, 8.4, the answer here is 131.92 meters, and this is greater than 83.32. Okay, so this is greater than S is equal to 83.32. Therefore, it is okay. Assumption correct. Therefore, L is equal to 131. So again, let's see if we have this. So our design speed in the problem, our design speed is 60. So it is 60. So here for the minimum design for L, nope, this isn't one. We're not going to use that. So our A is, in the problem, our A is 8.4. So letter B does not apply also. This does not apply. This does not apply. Therefore, the final answer there is the value. So the final answer for L, therefore, is 131.92. So this is the correct L. Let's go to the second problem. Before that, screenshot first the problem number 1 as reference. Next, example number 2. A vertical summit or crest curve has tangent grade of positive 0.5% and negative 1.0% grade for a road which provide a stopping site distance of 190 meters. So given the stopping site distance for 190. Height of driver's eye above the pavement is 1.07 meter, and the height of the object ahead is 0.15 meter. Compute the minimum length of a crest vertical curve for a design speed of 100 kph. So we're looking for the minimum length of a crest vertical curve. Now let's have this assumption. First, let's write the given first. So our given a while ago is we have G1. Where do we put it? So we have there G1 is equal to 0.5%. G2 is negative 1.0%. S of 190 meters. Height of the driver's eye 1.7 meters. Height of the object is 0.15. The design speed V is equal to 100 kph. Okay, now we will be solving for the compute the minimum length. We are solving for the minimum length of the crest. So we're looking for L here. Okay, so we are making some assumption that S, or here the 190, is lesser than L. Anyway, we can still check if our assumption is correct later on. So first, let's solve for the A. A is G1 minus G2 in percent. So G1 is 0.5 minus 1, no, negative. It is negative 1.0, and that is equal to 1.5%. Now for L is equal to 1.5 times the S of 190 squared, 100 times square root of 2 times 1.07 plus square root of H2, 2 times H2, this is in squared. So what is now the value of L? So it is 133.95 meters, and it is less than the S of 190 meters. Therefore, is our assumption correct? No, it is wrong assumption. Therefore, use S is greater than L. So we will be using the S is greater than L formula. So here we have. Now let's compute for the value of L. We have there L equals 2 times 190 minus 200 times square root of 1.07 plus square root of 0.15 squared all over value of A is 1.5. So this is 110.5 meters, and this is less than the S of 190 meters. So okay, assumption correct. But we will still have to look for another one. We're looking for the minimum length of the highway. Now we will check here. Since our design speed is, where's our design speed is 100 kph, then to which it is applicable. If speed is 100 kph, so not this one. Oh. A, what is the value of our A a while ago? A is, our A here is 1.5%. So when grade breaks, A is equal to G1 minus G2 is less than 2%. Okay, so we can use B. Then velocity, so this one is here applicable, but the grade break is greater than 2%. No, this is not. So we will not be using A, we will not be using C. Then D, when V is greater than 60 kph, correct? And grade break is less than 2%, correct? So we can use D. So B and D. Both says use L minimum of 60 meters. So that is in the code. Therefore, you can say here but V is equal to 100 kph greater than the standard 60 kph, and since A is less than 2%, use L is equal to 60 meters. Then we're looking for minimum, isn't it? And L is equal to 60 meters is less than 110, this one here, 0.5 meters. Therefore, use L minimum equals 60 meters. Okay, so that is the answer. Okay. Screenshot the sample problem number 2 and the solution. Right, let's proceed to the last problem, number 3. For problem number 3, a vertical parabolic curve has a sight distance of 130 meters. The curve has tangent grades of positive 2.8% and negative 1.6%. If the height of the driver's eye from the pavement is 1.08 meter and the height of the object is 0.5 meter, compute the maximum speed of the car that can pass through this curve. So we are going to compute for the maximum speed of the car. Okay, so let's have this assumption once again. So we have there S is lesser than the length of the curve. Now let's write the given. Has a sight distance S of 130 meters, tangents or grades of 2.8%, G2 negative 1.6%, Height of the driver's eye from the pavement is 1.08 meter. Height of the object is 0.5 meter. And then we are to find the maximum speed of the car that can pass through this curve. Okay, let's solve for the value of the grade break or the difference in grades. So we have there A is equal to 2.8 minus negative 1.6. And the value here is 4.4%. Okay, so assume S is less than L. So let's have the value of L. A is 4.4% times the S of 130 squared over 100 square root of 2 times 1.08 plus square root of 2 times 0.5, that is squared. Value of L is 121.91 meters, and this is less than S, which is 130 meters. Now, is the assumption correct? Now take note that S should be lesser than L. Therefore, assumption is wrong. Therefore, use S is greater than L. Okay. So here we have it. S is greater than L. So value of L now is equal to 2 times 130 minus 200 times square root of 1.08 plus square root of 0.5 squared all over grade is 4.4. Okay, so our L here is 121.38 meters, which is less than the S of 130 meters. So, okay, assumption correct. Now, what do we do with this? Let's go to the design criteria here for don't know yet what is the design speed, but let's base it with the grades. So what is our grade a while ago? 4.4%. So in B, when grade breaks A is less than 2%, so this is not applicable. For letter C, the grade break is greater than, so it's 4.4%. If grade break of 4.4% is greater than 2%, yes, we can use this one. When the grade break 4.4 is less than 2%, we cannot use that. Okay, so we are going to go for C. Okay, use L is equal to twice of V. So let's go to the problem. Since A is greater than 2%, use use L is equal to 2V. Use L is equal to 2V. Now, how do we check for it also? Well, if the value will come out, the V is greater than 60, no, not that one. If V is greater than 60, then this is all correct. Okay. So, since our L is, we're going to use this one, the 121.38 is equal to twice of V. Therefore, design speed is now equal to 60.69 kph, and this is greater than the 60 kph. Therefore, it is okay, and we will be using this answer. Okay, so this is our answer, the V, because it's something that we're looking for. So, for example, number 3, have your screenshot. Okay, so that's all for vertical, crest, or summit curve. We will go for the next video. We will discuss the sag vertical curves.